Good morning. How's everybody doing out there? It's going to be a busy day today. Want to kind of kick things off here with kind of the future of the data center talk. So I'm excited to be able to do that. My name is Clint Luderman, and I am the product marketing manager for Western Digital. So I may be making some future-looking statements that may or may not come true. So I guess that means you can either believe me or not believe me. But hopefully, kind of set the stage here with what you guys are doing. You're obviously at the show. And the show is about the leading edge of data center design and what's going on there. And so if you start to think about what goes on in data center design is you basically have to choose the right storage. Storage represents usually around 37% of your build dollars that go into it. So it's a pretty significant, it's an investment you want to make wisely on there. So if you think about kind of an app and the types of storage and decisions that you might actually have to make, think of like a ride-sharing app. You may have millions of users and you may have billions of transactions that you have to basically store and deal with. If you start to think about it and you have an app and you download the app and you're saying, I want to go get a ride, that app, where did it reside? Well, currently it's on your phone, but you downloaded it someplace. Normally when you download it, it's going to come from a cloud. And you have one copy and that's got to go to 1 million users. So in a scenario like that, the storage for that, now while you might want to cache and have multiple copies, you can have kind of one copy and be able to read it 1 million times to be able to give it to the different consumers that are going to download it. So this whole concept of kind of a very read intensive would play there. If you then go and think about, now I've got this app and I want to find out and I want to get instantly know where my driver is and how far away are they. Well, now all of a sudden you're talking real-time analytics. And the type of storage often there might be DRAM, but you might actually have maps and have background information stored on flash storage. And then the other thing you think about is you go, today's Thursday. What am I going to do on Thursday? Is it a normal day like Thursday where there's a lot of people moving around? Or is it Thanksgiving? And you go, well, is Thanksgiving busy? Or is it not? Is it busy because everybody's going to grandma's house to get turkey? Or is it not busy and there's actually no drivers because everybody's passed out on the couch watching football? You know, so you have this whole kind of things that you are going to answer that question. You're going to have multiple years of Thanksgiving data. So keeping track of this data over years worth of time and building up a big data pool is going to take a lot of storage, and you're going to have hard drives probably being able to store that and do those sorts of analytics offline. So one of the things as you start to look as things move forward, what are the big changes in the data center? Well, we talked about things being very quick, and one way to do that is looking at NVMe. So on the SAS, or on the SSD side, you have a lot of products today are still using SATA to be able to do the transport. So this chart that I'm showing up here in the blue, you actually see the SAS, and you see SAS kind of continues, and it continues eventually, and it turns into the green, which is on the right-hand side of the bar. And eventually, it's all going to go to NVMe. But the important part is that most people in this room typically don't use SAS for their hard drives nor for their controllers. That's typically a legacy enterprise interface. What a lot of people are doing today is using SATA, which is shown in the gold in the middle. And if you look at the 218 going to 219, all of a sudden you start to see that SATA is going away. Look at 2020, it almost halves again. And by the end of 2022, you really don't see SATA anymore from an SSD perspective. And so that's kind of a big thing that we want to talk about is as you're designing your new servers to be able to look ahead, to be able to reduce the latency and to be able to do the types of apps that need to be done, you really need to start moving to the NVMe as a platform. When we start looking and how we kind of have divided up and say, how do you look at NVMe across the board? What types of segments might you classify the different products in? And what we have on the left there, going from left to right, is kind of by endurance. So the idea on the very left column is to have very read intensive. And the idea behind that is kind of that example where I may have one app, it doesn't change very often, but what it does do is you now need to read it multiple times. So if you're caching an app store, if you're caching a library full of music, caching videos that don't change very often, then very read intensive, where you write very little, very read intensive are things that work today for a boot drive, but they also work when you start to see things going in the future into QLC and some of the things that have lower endurance levels, you start to see a swim lane where write once, read many is sort of the motto here. As you move into the RI storage, which is really read intensive storage. Now this is kind of where you have mixed storage. A lot of SSDs I think are going to be sold in this category because you don't know how much. You don't know what the apps are going to do. You don't know how much you're going to write. So therefore, although it's read intensive, there's still a pretty hefty 70-30 type read to write ratio in there, and this is really going to be your mainstream workhorse. As you start to move up into the cache and compute, you'll start to see that there you're actually doing a lot of writing. You have much higher endurance, more drive writes per day, all the way up into the accelerators, where you start saying, how do I use flash to basically do a cheaper version of DRAM and be able to store more cost effectively. And so we have products that kind of cover all these. You're welcome to come over and see us. One of the products that we did announce in this read intensive is our 630. The DCSN630 is a data center class product. It has data center specs on it. And in there, you're starting to see that the capacity points are kind of getting out of the boot range. So instead, you're starting at 1 terabyte and below is really kind of the starting point. 1 terabyte going to 2, 4, and 8, rounded off for memory capacities. You know, so the maximum is a 7.68 terabyte. This is the type of product you're going to see, which is going to be your mainstream workhorse for the bulk of your business. The drive writes, if you look at something, you want something really flexible. If you look at this, can do a 2 drive write per day. So it kind of blends between a read intensive and a very read intensive, and you can switch it back and forth between a 2 drive write per day mode or a 0.8 drive write per day mode. So good mixture. You trade off a little capacity to get a little bit higher endurance. When you look at IOPS compared to a hard drive, especially when you start to move up, the hard drive can store a lot, but it doesn't have the IOPS. When you start getting users on the other end, you're actually going to want to be able to get that lower latency. That's really where the NVMe comes in and is able to take advantage of the higher IOPS and higher bandwidth that NVMe can offer. Power is another thing you're going to have to worry about. You want to make sure when you pack an enclosure full of SSDs that you have enough power to be able to power them up. So getting something that has a lower power profile, like this product is around 10 to 11 watts, is ideal. Security becomes a bigger issue. This product, across the board, instant secure erase. That's where you're using kind of background encryption. You want to be able to tell it to instantly erase it. It loses the internal key, and now you have a drive. You can now redeploy that drive or retire it, knowing that consumers' data is safe and cannot be accessed. That's the feature you're going to want to look for these types of products. And of course, you want to make sure you're enterprise class and have the 10 to the minus 17th as kind of the uncorrectable bit error rate. And that's an area there that you have on the enterprise. And of course, doing something with like 3D TLC is going to give you the right performance that you need. If you look at the types of virtualization, object storage, and maybe NoSQL are different use cases that you can use are typical. They have a lot of mixed workloads. You can imagine when you're virtualizing a system, you have a lot of software at the high end, and all those things are going down to the SSDs at the bottom. You don't know what's going to happen there, or you don't know the I/O patterns on there, so you want to basically have very high-performing drives that are underneath of there. The object storage kind of example allows you to use the high endurance and low endurance modes and be able to switch between them. So you can use higher endurance for journaling applications, and then the lower endurance where you just want to store the data and it's not quite as active as a workload. So let's kind of switch over here, kind of talk a little bit about hard drives versus SSDs. Western Digital is kind of unique because we actually sell both, we understand both markets and can see it. When you start to see in the press, oftentimes they'll say that the SSD is going to kill the hard drive. And you'll notice the dotted lines at the top where you have NVMe and SATA SSDs. We're starting to see those converge from a pricing standpoint here. You think over the 2019, 2020, that all of a sudden you're going to get close enough pricing that it makes sense to move to NVMe. And then if you look at where a 15K or 10K hard drive, again, most people in this room probably don't even use 10K or 15K. Most of them are traditional enterprise. So often when you read in the press, they'll say, oh, it's going to take over. And you can see that even with a 10K hard drive, you're still, SSDs are higher priced. Maybe with 15K on $1 per terabyte, you're starting to see some parity there. So make sure when you're hearing about the death of the hard drive, they're certainly not talking about the 7200, 10 terabyte, 12, 14, 16 terabyte hard drives that are coming out today. That's the blue line at the bottom. We still see a 10x difference between hard drives and the SSD line. And then when you start to put QLC in there, you're really just seeing maybe a 10 or 15% drop down below where the current NVMe and SSD lines are there. So just be aware that storage is going to be made up probably of a lot of fast SSDs and big buckets of hard drives, and that's really the architecture that's being adopted by the cloud and hyperscale market more so than the enterprise side. So what's driving our ability to kind of keep that curve going on the hard drive side? And we've got several technologies that are basically driving this. If you look at one of the big ones we're starting to see take off is SMR. That's one that takes a lot of software. So if you're on the hardware side, you might say, I want to take advantage of it, but you really need a software stack that can actually take advantage of SMR. And so it really requires somebody who owns the software stack that you're partnering with. Dropbox is one that we've worked with. We've written some blogs with them, have been able to take out and take advantage of that. And so they've actually owned their stack. They can talk directly to the hardware, been able to get a pretty big gain, and now they can leverage that and get lower dollars per terabyte. If you look at the other ones, things that we've done internally, we've gone to larger disks, gone from like 95 millimeter in a diameter disk to a 97, so it makes the disk bigger. We're able to stack higher. We now can go up to 8 disks on our platform, and probably more to come there. If you look at the internal, the mechanics, the micro actuation, that's really the mechanical design of controlling the head, moving back and forth, a lot of innovation there of moving the head closer and closer out and be able to control it further out at the very end of the tip, which gives you the mechanical margins that you need to be able to squeeze those tracks closer together. And of course, our damascene head process is how you actually make the head. Instead of using the old dry pull method of etching away to create a head, we use a semiconductor process where you're building up by different layers, gives us a very fine head. So a lot of guts inside of it. We've shipped over 40 million of helium drives, which have all these technologies in it. So it's been very successful at continuing that ongoing curve and keeping the terabytes higher, which brings the average dollar per terabyte down. So then the question kind of becomes, why do you want to do that? And if you look at this on here as kind of a TCO, is if you go to the highest capacity, that's the best way to get better TCO. And you can lower your cost by 25%. So this is a kind of an example that shows in the top right, if you have a chassis, and this is like a 2U by 12 chassis, and you make an assumption that half the cost, 50% of the cost, is the hard drives, and 50% is the other. And other can be the DRAM, the CPU, the motherboard, the internet card, all the shared costs, the top of rack switch, anything else that's associated that's not a hard drive goes into that other bucket, and you're assuming a 50-50 ratio. Well, if you do that and you want to build a Ceph cluster of 4 drives of 2U, or 4 servers, that gives you an 8 terabyte versus 16. Your 8 terabyte cluster in yellow is going to have 384 terabytes. You're going to get twice as much, obviously, if you substitute those 8 terabytes with the 16 terabyte. You'll end up getting 768 terabytes. So you double capacity. Of course, it's going to cost more, but the end is when you look at $1 per terabyte, that's where you actually save your 25%. You get a power savings going from 8 air into helium. Helium has an advantage there. And certainly when you actually look at the extra capacity, you're saving 61% of your power savings. That means if you have a big photo application and all those photos are sitting out there doing nothing, waiting for somebody to access them, all of a sudden you can cut your energy bill in half with them sitting there doing nothing by going to the higher capacity and being able to get a better watts per terabyte ratio. And again, I'm assuming the $1 per terabyte, that a 16 terabyte costs twice as much as an 8. You can actually probably get a better deal than that. So this assumption says it is at parity. And if you do the math, it's really kind of a 50-50 of the hard drives and other. And an 8 versus a 16, if they cost the same, then you're end up going to save 25%. And that's what's driving hyperscale applications, the public cloud, the private cloud, that wants to reduce their storage cost, is figuring out ways to be able to utilize higher capacity hard drives. So again, we really talked about SMR. We have a 15 terabyte SMR today. I really point this out because we've talked about it for several years. It's been out, and we're really getting to a point that the software stacks that are there are being developed, that people are able to take advantage of it. And it does require an investment. So if you're on the software side, come talk to us about what it takes to do. If you're on the hardware side only, you really need to find the right software partner to be able to take advantage of this technology. So real quick, I kind of want to talk about technologies that are driving enterprise stuff in the future. And this is really our dual actuator. It is something we do have in our booth, so you can come by and see it. So it's a technology demo. And the idea behind this is, as I talked about, is how do you increase the IOPS? on a hard drive. And we're really not talking about random IOPS like you think of an SSD. You're really saying, I got a bunch of photos on this disk, how can I get twice as many photos off the drive at the same time? And the problem is as we've gone higher and higher capacity, we've gotten less and less ability to be able to keep up from a performance. Doing a dual actuator splits the actuators, and we have it on there, so it actually splits. You have 4 on the top disk, 4 on the bottom, and they're actually basically able to access the data at the same time. So it's really 2 disks in one, in the same sort of form factor, and that's where we're at. So come on over to the booth and be able to see that. We have a full product line, so the key point here is make sure when you're choosing your storage, you want to work with somebody who has all the options, whether it's NVMe SSDs, SAS SSDs, even the air hard drives, or you actually want the highest capacity drives. You want to be able to partner, so come over and check us out. Appreciate all the time that you have here and that you spent taking time out of your morning. Thank you.